Hey everybody, and welcome to another episode of Manhsplains. In the tradition of Manhsplains, some people are having a conversation on the Touchdesigner help forum, and I'm just gonna bust in and explain things without being asked to. True to keeping. So, people were discussing how this effect was made. This guy Olivier asked this question. And it looks like some people thought whether or not it was augmented reality, but it looks like this guy's actually carrying a bunch of boxes that are colored, connected to a stick, and there's a movement, camera movement, halfway through the camera pans to the right, but there doesn't seem to be any parallax to that camera, so it's just purely a rightward movement. And I think it was just probably shot with a higher definition camera and then cropped down and moved to kind of give you the illusion. There's a lot of things that are illusory about this, but the main part that gets you with the camera movement is it looks more real. Um, but the boxes are all bright and highly saturated. So I was thinking, if we just kept whatever pixel that was brighter and more saturated, then you basically could just redo this effect live rather than this looks like it was done in After Effects. So I decided to explain how I would go about doing it. So I'm going to turn off the display here. Hitting that blue button makes things display on the background as you saw there. It's very helpful. And so the first thing I'm going to take in is it's a camera. I don't actually have like a full-blown webcam, but I have a connect-to-sewer, so lucky me. First world problems. And I'm going to actually try to do a pretty high-ish resolution. Let's say 2048 by 1536, and I want the color image. So there I am, my pretty face. And then from there, it's gonna feed into a feedback top. Now, a feedback top just takes in a frame, a single frame like this, and then something happens to it. In this case, I'll do a GLSL, which is my favorite thing to do, because it lets me write code, and then it goes to a null. So basically, feedback goes through some kind of change. It takes in a frame, goes through some kind of change, and then that change goes back into it. So in this case, this GLSL just draws white, and then that goes into it, overwrites, and then so this GLSL gives us some control, some programming control, and for it I'll need the current camera frame, which goes in the second input, and the feedback, which goes into the first input. So for those of you who are unfamiliar with GLSL, let me do a little mansplanation. Alright, so here you can see shader, pretty much a fragment shader, a pixel shader in this case, is a program that runs on every pixel that gets fed into it. So into this thing there's two inputs. The first input is a sampler, and actually let's just think about this. It has a color. In this case it's 4 times 1.0, so there's RGB and A. They're all 1, then you get white, right? So OpenGL goes between 0 and 1. Familiar with web colors, they go between 0 and 255, or #0 and #FF. But if, for instance, we did color equals like 4, or actually just color.r, right? So you can actually address the R, G, and B channels and A channels separately. Let's say I made that, actually it already is 1, so let's say equals color.b equals 0, and suddenly now it's drawing red. So that's helpful, and then that gives us some power later on. We can use that to inspect things. So here, instead of just drawing some color out, it's actually taking the input, right? So this is S is a sampler, which is the inputs, the kind of input. If you're a texture that goes into this, this is just a specific to Touchdesigner. It's Touchdesigner 2D inputs 0, which is the first input, and this just tells it where to look, which is the current pixel that you're at. Now it looks exactly the same because the feedback input is red. But if I like reset the feedback, now it just draws whatever the feedback has. And then that goes back out to the null, which goes back into the feedback. So great. So what do we want to do? We want to move, or I'll just make this thing bigger. Hit P to get rid of the parameters. I want to move this battery across the screen. This battery is bright and blue, kind of like this box is. And everywhere that the battery's been, I want it to stay the battery. Everything else is live. And some cool things that you see inside of it is, in that video, you see him walking in front of some trees, walking behind some trees. I guess it's not there anymore. And the trees stay in front of him. So if there's something in front of you, you want to actually not, you don't want to overwrite that. And that's just, that'll happen here because we'll never be in front of the things in front of us. That's kind of the definition of that. So, without much further ado, let's consider this input, the last frame, right? So last frame equals the feedback input, and it doesn't look like anything changed here. Sometimes what I like to do as a sanity check is just break stuff. So if I hit save here, then you see it doesn't work. Something's not right because my syntax is all wrong. So it reads the pixel from the last frame, and then, because I'm lazy, it also reads a pixel from the current frame. I'll just copy and paste. And that'll be input from this one. So let's say instead of drawing the last frame, I draw the current frame. Current frame, I'm making a silly face. What is up with my Connect Azure? Did I hit space? Oh, there we go. I paused it. So now the current frame, let's undo that again so you can see the difference. So with the last frame, there's no more movement. Current frame, there it is. So sometimes we want to draw the pixel from the last frame. Sometimes we want to draw the pixel from the current frame. In what case do we want to draw the pixel from the last frame? Well, whenever the case is whenever it's the battery in this case. So what separates the battery from everything else? I'm wearing a black shirt, so, and I'm not that brightly colored, so pretty much anything that has a higher saturation, it's probably gonna work for you. So I pasted in here the GLSL code for converting RGB to HSV. That's just a function, and so then I also, and it takes in a vec3, right? So the last frame is vec4 because it also has the alpha channel. We don't really need the alpha channel when we're calculating the HSV. So we want last vec3, last HSV equals RGB to HSV last frame, and then you select just the RGB components. If you passed in all of last frame, it wouldn't work because it's looking for a vec3, which is RGB, and you'd be passing in a vec4, and it'd be a type mismatch. And then you can do the same thing for current HSV. Alright, so now we have the last frame and the current frame's HSV. So let's say we do, how do we access this the saturation value? Unfortunately, GLSL doesn't use HSV, so we could say, you know, last HSV would be the second thing. So with RG&B, it could be G, but that'd be problematic because you don't want to conflate those two. But the GLSL also does X, Y, and Z, right? So X, Y, and Z is the first, second, and third channel, and it's interchangeable in this case with RG&B. So how about whenever we're talking about HSV, then H is X, Q is X, saturation is Y, and Z is value, which is how bright it is, and it's going to be between 0 and 1. So if last HSV dot Y, which is the saturation, is higher than current HSV dot Y, then current frame equals the last frame. So now it'll just override the last frame. Let's see what happens. I hit save. So yeah, so whenever my skin seems to be more saturated than my hair, so that's kind of cool. I'll turn off the Azure as the input. So great, that's kind of cool looking, but not very helpful. So we'll want to reset feedback. Feedback will just take all of the input from its first input whenever you hit reset. There. So now you have it. So apparently that's not enough. Just checking if the saturation is higher won't work. I don't want me to be a part of this, right? So one thing that we do know about this is that the battery is quite blue. So let's just check if if it's more saturated and the last frame. So here we're looking at the frame itself, the RGB value, and not the HSV value. Let's say the last frame is higher than the blue value, is higher than 0.5, which is really high actually. So here it's mostly overwritten. I guess there's more blue, more than 0.5 blue right here, but let's try it with this battery, huh? Works pretty well already. You notice in the video, in the original video, he moves nice and slowly, and now you can kind of understand why, because if you move slowly, you have a more solid color than if you move quickly. Okay, so let's pulse that feedback. We're close, but it's not quite there yet. So the last frame, that B value is higher than 0.5. And let's say we want it to be pretty bright. So I want the blue value to be the last thing it checks. So in between, I'll do last HSV dot Z, right? The last frame to HSV dot brightness or value is larger than 0.3. Okay, that's not getting rid of my weird outlines here, my Bruce Lee style outlines. So let's say, I get rid of some of it. That's actually way too high, because that's actually not going to work at 0.8. We might not get to keep any of this. Oh, we do, but not always. Let's see. And then in like slightly different light, you'll lose it. So that's closer, but that's still not it. Let's say not just whenever the last frame's saturation is higher, but let's just say it also has to be, than the current frame, but also has to be just higher than 0.6. Let's try that. There we go. Now that got rid of my head hanging around. I think my blue requirement is a little high. So instead of 0.5, do a 0.3. Let's see how that, I'll just reset it. It's weird that it wasn't working over here. Oh, yeah, I guess it's just too dark here. But it's not too dark up here. Interesting. Light impacts us a lot. You can see why he chose such brightly colored boxes. Let's swap over and try it again. So now we're requiring too high of a brightness. Let's say more than 0.1. That's much lower. Cool, I'm not leaving a trail. But this thing is, and there you have it. But it looks kind of cheap, like anybody could do this with just a camera that's not moving. Let's try this. I have this box that's low saturation, just like those trees were low saturation in the foreground. My premium tempered glass protector for my phone. So how do we get the last part of the illusion? We crop it. So let's put a crop on it. So now this is what we're going to look at. Now if you look at this, you can crop the left of it, or you can crop the right of it. And so I just kind of want to crop the same amount, or crop some amount off the left and the opposite of that amount off the right, so that it's always kind of the same. You don't really want your video shrinking and growing as it's happening, you know? So human hands move in kind of like a noisy way. Human everything's moving in a noisy way. So if I was a cameraman and I was moving the camera from left to right, I'd want, let's say, some value that's always less than 1, let's say less than 0.4. So this has an amplitude of 0.2 from 0.2 down to negative 0.2, and then I want to offset it by 0.2. So now it's from 0.4 to 0, right? And, you can move the seed value around. It'll never go higher than 0.4, and it'll never go lower than 0. But I need that value to change, so I'll just take a time slice of it. And there we go. Now we can drag this into the crop left, make a chop reference of it, and then I can do the same thing into the right. And that's not really going to work. It'll just give you a single line. So it's actually 0.5 plus that value, and there you go. This really noisy left and right hand movement. Let's calm that thing down. The way we do that is by increasing the period. There. And to also make, let's just copy that and paste it. Well, let's move the camera up and down a little bit too. So let's say I have a smaller amount that it moves up and down, 0.1. And then I change the seed a little bit so that it doesn't look exactly the same. Do the same thing. Chop reference. Chop reference, I'm going to get a single pixel. And I'm just going to add 0.5 to it. There. Now it looks like there's a really shitty cameraman moving his camera around. I should bleep that out, but I won't. Let's give it a different period. And actually, that's alright actually. So let's reset. and see how that works. Here I am just hanging out behind my glass protector when lo and behold I decided I want to start drawing. I've got my shaky-handed cameraman. Apparently he wants to go up and to the right, and then back, whatever. And then I'll just move this away. Note like the direction that the battery is facing impacts things as well. And the battery, I guess, reflects my shirt. So it's like a different color when it's over me than when it's not. But if I had like 4 boxes on a stick, then you get it. So there you go. Unnecessary amounts of exposition for what is like 1, 2, 3, 4, 5 operators, 7 operators. And that's your mansplanation for today. Enjoy.